Welcome back, fellow coders. I'm here with another kata challenge, and this time we're doing a level 6, and it's called Financing Plan on Planet XY140Z-N. And I'm assuming that's a fictitious planet, and well, we're going to be learning a cool way to add numbers, consecutive numbers, without using iteration. So let's get started. So we are in the page here, and I'm going to put the link in the description. Okay, so as you already know, we always start by reading the description of the problem for the kata. And this description is not the best one I've read here. As a matter of fact, it's a bit confusing, and you can see that on the discussion tab where some people are saying that it is, in fact, very confusing. So instead of going through this mess, I'm actually going to show you on the slides what we have to accomplish. Okay, so I'm using new software here just for me to draw things on the slides. Was a bit hard to do that on Keynote. If anybody knows how to do that in Keynote on a Mac, let me know. But so I'm just going to do this here on the sketchbook. So these are the things that we're going to talk about. I'm going to show you what we have to do, and I'm just sort of translating the description into easier words. We'll go over ways to solve it. Then we'll do the pseudocode, and we actually code it at the end. Okay, so the kata description, it's not very hard. So we have a function called finance that takes an argument called n. And n is the parameter for the number of days and also for the number of weeks. So if we have a 5, then that means there are 6 days and 6 weeks. So since we start counting at 0. And I'm going to show you that in a few with an example. And finance needs to return the sum of all the savings for all the weeks. And that's the main problem that we're trying to solve. In the kata, they tell us that we can't use a nested loop. So you can't have a for loop inside a for loop or a while loop inside a for loop. Whatever kind of loop, it cannot be nested. And so that's where we have to come up with another creative way without using a nested loop. And so if you've never added consecutive numbers without using a loop, then you're going to learn something new today. Okay, so in the kata we have this picture of the table, and the three things that we have to keep in mind as we go through each iteration are the number of weeks. So we have to basically have a week counter, and we can use the counter for the loop for that, since we start at 0. So we'll start and at 0, and then we'll go up through the iteration on the for loop. So next big thing that we need to take a look at is the first number of the week. On the first week, we don't use 0 because, as you'll see in the next few slides, the formula that we are using cannot be using 0, otherwise it will throw off the formula. So we'll start with 1 on the first week. We'll have to keep in mind all of these first numbers. And let me choose a different color for the last number. And you'll see in a minute why I'm circling this. So this is a small week. It's only 7 days in seven weeks. So it's it's not a very complex in terms of timing. But if you have 500 days in 500 weeks, then adding this in an iteration, 1 plus 2 plus 3 plus 4 plus 5 plus 6, is going to take some time. So it's better to use a formula. So in short, these are the variables that we need to take care of. The weeks, the first number, and the last number. And we also need to return the sum. So I'll have already added these numbers here, and this will come in handy when we are doing some debugging. And this is kind of funny. When I was going through this problem, I noticed that there's also a pattern here, and I don't know if you can see it. And this might be even another way of solving it by using this pattern. So maybe another person looking at this pattern can come up with a different formula than what we are doing today. Okay, so what are some ways to solve this problem? So the very first thought will be to use iteration, right? Be to use a for loop to keep track of the weeks, and then use another loop inside that loop to do the summation of the days. But since we can't use another loop, then we have to come up with another way, and that's the way of adding consecutive numbers with a formula created by Gauss. I hope I'm saying that correctly. He was a mathematician way back then, I think in the late 1800s, I believe. And the formula is quite simple, and you'll see that on the pseudocode. And as I've already talked about, these are other important variables: the week, first and last, and also the number of integers for the week. So if we go back on the first week, we have 1, 2, 3, 4, 5, 6 integers. So that's actually our parameter, right? The second week, we also have 6 because, well, we had 7 on the first week, but we can't use 7 to keep things simple for the solution. So we have 6. So in the program, we're just going to say that the first 2 weeks have the same number of integers. So this one also has 6. And in the program, we're going to say, okay, the third week, that's when we need to start subtracting. So we'll say -1, and it's going to be 5, 4, 3, 2, 1, and so on. And so that's what we have to do for the number of integers for the week. For the rest, we already talked about. We have the first and the last number. And we need to return the variable with a total sum. So now let's go over the pseudocode. This is where the fun begins. So we have the finance, and this is just pseudocode. This is not Java or Python or anything. So if you are watching this and you don't, let's say that you don't like Java and you want to do this kata in a different language, then you can do so just by following this pseudocode. So we'll initialize the variables here, The first number is always going to be 1 and not 0. These two are pretty simple since they are using the parameter, which can be anything, any integer. And then the total sum will start the total sum at 0 since we haven't actually added anything. Then on the for loop, we'll have a local sum integer, which is going to be just sort of a local variable that we're going to throw away on every iteration. And this orange part here is actually the Carl Gauss formula. So we have the number of integers, it can be any number, divided by 2 times the sum of the first and last number. Once you have that, then you add that to the local sum here. So, as an example, the number of integers on the first week is 6. We divide that by 2, it gives us 3. The first and last number, the first number is a 1 and the last number is a 6. No, I'm sorry, it's 7. Let me just make sure. One and a 6. Yeah. Then we add the first and the last number, which is 7. 1 plus 6 is 7. We'll multiply 3 times 7, and that gives us 21, which is what we had on the first week. So it's a pretty simple formula without having to use iteration. As I said, this is not a problem for a parameter of 6. But if you put a parameter of 2000, then things are going to be quite slow when you are summing all those numbers. So the next thing we need to take care of is adjusting the variables for the next iteration. For the last number, it's pretty simple. I'll show you on the table. The last number, which is this one, it's just going up by 1. So we are just upping that one by 1 here. We have to make some conditions here because the problem with the 0. If we didn't have a 0, things would be much easier, but we do have a 0, so the first 2 weeks, week 0 and week 1, are sort of special because we have the same amount of integers. So if it's week 0 and 1, we don't want to subtract the number of integers. So we are just starting at week 2. And also the first number is special as well, because if you see the first number here is 1. And then here is 2, so that's just adding 1. But after that, we are in 2 all the time. 2 plus 2, 4, 4 plus 2, 6, and so on. So that's why we have these 2 check conditions here. So at first, the week 0, we add only 1 here. If it's a week after that, we add 2. And also subtract the number of integers here. The last condition is also very important because this means that we have reached our last day. If the first number and the last number are the same, then we are on the last week, and we can just exit out of the loop and add that to the total sum And finally, we return the big total sum. So this pseudocode is very handy because we don't have to worry about typing variables, actual variable types, and syntax that gets in the way of thinking about the problem. You can literally take this pseudocode and solve it in any language. So that's what we're going to do next. We're going to get into the Java code. So as you already know, we always copy the bare bone code that is in Codewars. So in this case, I've copied the finance class and finance method, and I've already copied and pasted the finance test. So if you don't know how to do that, then I suggest you go over the first few videos where I actually do that. I'll put the link in the description. Okay, so following our pseudocode, we'll start by initializing some variables. The very first thing, I'm going to declare a big integer because that's what we have to return, and I'm just going to call total sum, and we'll start that at 0. By the way, if you've never used a big integer type, and that's a big class, and in IntelliJ you can actually go to the declaration and you can look at all the methods available and everything in that class. Just an FYI if you didn't know this. So once we have that, we can return the total sum, which at this point is just 0. Then we'll do our important variables. First number, we'll start that at 1. Last number, we'll start that at n. And the number of integers is also starting at n. And if you didn't remember from the pseudocode, this has to be subtracted after the second week. The last number has to be added 1 every week. And the first number, we add 1 the first week, and then we add 2 after the second week. And I'll just put that there just for your reference. Okay, now for the for loop, we're going to iterate n times for the number of weeks. We'll create a local sum, start at 0. And here is where we are going to use Gauss formula, which is not very difficult. It's just a very handy formula. So the local sum will be equal to this formula. So the number of integers divided by 2 multiplied by the first number plus the last number. And that should give us a local sum for the week, whether you have 6 days, 7 days, 1,000 days, 2,000 days, whatever many days you have. This is going to give you the sum in a split second. Then we'll add the total sum. And there is a method, a built-in method in the big integer class that we're using. And here we'll put local sum. And because local sum is a double, it needs to be casted into an int. Okay, so that takes care of summing all the money for each day for every week. Now we need to take care of the iteration variables. So the last number is the easy one. We don't have to worry about anything. We just add 1. For the first number, if we are in week for the first number, if we are in week 0 and 1, we don't want to do anything with the number of integers or the first number. So for the first week, what we want to do is only add 1 for the first number. And for everything else after week 1, or actually week 2, then we want to subtract the number of integers by 1. And our first number, we are going to add 2, just as we explained in the pseudocode. And I'll put a comment here saying that for week 1 and week 2, there's already 6. And for week 1, I'm sorry, week 0, let's just say that it just gets a little complicated because everything starts at 0, but we're saying that week 1 is week 0, if I didn't make that clear before. So for week 1, we add 1 for the first number, and week 2, and so on, we add 2. I hope I made that clear. And you actually see that when we go through the debugging process. And so that takes care of our variables for each iteration. And well, that's very important, because if we don't get this right, then the sum is going to be wrong. Lastly, another very important piece of the code is that we have reached our saving goals. And the way we'll know that is if the first number is the same as the last number. And we'll do another add here. And we'll add the first number. Let's just say last number. It was the same thing, but just to keep things simpler here. Lastly, we'll break out of the loop, and we are done with this loop. So we only have one loop, as you can see. No nested loop here. The last thing, we'll return the total sum, and we are done. So let's run this. Let's actually run the example test, which is 6. I need to put a breakpoint, and I'm just going to put it here in the loop. And then we'll debug finance and takes a parameter of 6. And debugging is very important because, especially on loop, you get to see what's happening as the iterations go through and whether each iteration is correct. And so it's always important to debug your software, right? Okay, so we are starting the loop here. Local sum is 0. And then here we're using the formula. Number of integers is 6. Is the first week, remember. First and last is 1 and 6, just as we discussed in the example. So this should give us 21, and you'll see that on the local sum down here. So the first week is correct, and we'll just add in that to the total sum. The last number is just going to go plus 1. And since it's the first week, we don't want to subtract the number of integers, so this is going to skip here. We do want to add the first number 1. And this is going to skip over, it's not true. The second week should give us 27, if you remember. And we get 27. We have the last number by 1. Now we are in week 1 now, so we should decrement the number of integers. And so on. And the next 30. And 30 again. And then we should get 27. 21. And finally, we have saved all our money. And we can buy whatever we want. We have 156, and then we add the last number, which is 12. Or the first number, and that gives us our 168. We'll break, and then we'll return. So let's just go through all of the tests here. And all of our tests are good. Just a good thing. So as you already know, lastly, you can copy and paste the code in Codewars and submit it there and do all that fun stuff. So if you enjoy this kata, please give it a thumbs up, and just let me know what other challenges you want me to do. I have another one lined up from a user that I shall name in the next video. And it's a kata level 4, so it's going to be a little bit more challenging than this one. So thank you for watching. I really appreciate all the comments in the videos and requests. I'll see you on the next video. And remember to code with a purpose.